Approximation rules, you begin by finding delta x. So delta x is going to be, first of all, you find the length of the interval from 5 to 7, and then divide by n. So that's going to be a 2 divided by 10, or in other words, 2/10. And then the idea is you take that interval that goes from 5 to 7, and go over by 0.2. So this is going to be 5.2, 5.4, 5.6, 5.8, etc. until you get to 6.8 and then 7. So we're going to take all of these numbers from 5 to the 7 inclusive, substituting them into the function. The first one and the last one are not multiplied by 4, but this one, when you substitute it in, gets multiplied by 4, and this one by 2, and this one by 4, and this one by 2, and this one by 4, etc., 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 until this one is multiplied by 4. Because of this alternating of 4, 2, 4, 2, we can't really have the calculator do a sum sequence. We could have it at least generate the decimals for us, but this one's going to be a little bit tedious because we're going to have to deal with a lot of decimals. So to get the calculator to make those decimals for us, first of all, pretend like you're going to graph it. 1 divided by the square root of 1 plus 2x plus x squared. And then set up the table. So you have it start at 5, and the increment would be delta x, which is a 0.2. And then go to second table, and there's the decimals. So when you go over here, it will give you actually more decimals. So that my accuracy is 3 decimals in the end. What I'll do is use 4 decimals from this. So the first one, when you substitute in a 5, you do not multiply by 4. Okay, so the formula is it's delta x divided by 3, and then it's going to be f of 5 plus 4 times f of 5.2 plus 2, and then f of 5.4, etc., until you get to the 6.8. So it's going to be f of 6.8 gets multiplied by 4, and then f of 7. Alright, now we need to do all of this part, this decimal part. So first is f of 5, so that's a 0.1667. Next is going to be 4 times, this one would be a 0.1613, and then 2 times a 0.1563, 4 times 1515, and 2 times 1471, 4 times, look at that, we're almost halfway done, a 1429, a 2 times a 1389, next is a 4 times 1351, 2 times 1316, and we're almost done. This should be the 6.8. So 1282. The last one we need to plug in is the 7. That doesn't get multiplied by anything. That is just a 0.125. Okay, now we need to add those up. 0.1667 plus 4 times 0.1613 plus 2 times 0.1563 and 4 times 0.1515 and then 2 times 1471 times it plus 4 times 1429 plus 2 times 0.1389 plus 4 times 1351 plus 2 times 1316 plus 4 times 1282 and then finally plus a 0.125. Alright, so that's what goes inside the brackets. We then need to multiply by 0.2 and divide by 3. Multiply by 0.2 and divide by 3. And the final answer would be a 0.288. I quickly want to check the graph and see what it's supposed to be. So integrate. I think I need to change the window because this is not going out far enough. So from 4 to 8 would do it. Oh wow, that's a very short function. So then calculate the integral from 5 to 7. The answer, 0.288. Okay, well, we're halfway done. The midpoint rule goes very fast, so that's going to be, for part B, again, delta x equals a 0.2. The interval again goes from 5 to 7, so the first interval would go from 5 to 5.2. The last interval would go from 6.8 to a 7. Then you just need to know the midpoint in here would be 5.1. The midpoint in here is 6.9. And we can have the calculator add this one up for us. Sum the sequence. The width of each one of these is going to be a 0.2. And then the height of the function is given by 1 over the square root of 1 plus 2x plus x squared, and then until x goes from 5.1 to 6.9 in increments of 0.2. Let me just choose it over here if the glare isn't too bad. So then sum, and back to list, the sequence. The function is 1 divided by the square root. 1 plus 2x plus x is squared, with x going from 5.1. Did I put the 0.2 in there? No, I did not. So if I insert 0.2 times that, and it goes from 5.1 to 6.9, and the delta x is a 0.2. And based on the last one, the answer should be 0.288.